In this video, we are going to learn how to express trigonometric products as trigonometric sums. So I wrote the product to sum formulas at the top as a nice reference. So find the exact value of each expression. So looking at sine of 195 degrees times cosine of 75 degrees, neither of these angles appear on my unit circle, so they're not part of any of those easy reference triangles. But I can use the sine times cosine product formula in order to figure out the value of this expression by going from my product to a sum. I'll let 195 be my alpha and my 75 degrees be my beta. So using that formula, I get 1/2 of sine of alpha, which is 195 degrees, plus beta, which is 75 degrees, and then plus sine of alpha, which is 195 degrees, minus beta, which is 75 degrees. So using this formula, I can get 1/2 of sine of 195 plus 75, which is 270 degrees, plus the sine of 195 minus 75 degrees, which is 120 degrees. So I define this value, and you find sine of 270, which is the very bottom point on the unit circle, which makes this equal to -1, plus the sine of 120 degrees, which that appears in our second quadrant, but the uppermost angle in our second quadrant, which makes that equal to the square root of 3 over 2. So if I distribute the 1/2, I can get -1/2 plus the square root of 3 over 2. And I can combine square root of 3 over 4, not 2. And I can combine these two fractions by finding a common denominator. Give me the square root of 3 minus 2 for that 2 over 4, all over 4. Let's do this with another example. So here, I have cosine of 285 times cosine of 195. And I can use the product to sum formula. Give me 1/2 of cosine of 285 degrees minus 195 degrees, and then plus cosine of 285 degrees plus 195 degrees. So I get 1/2 of cosine of what looks like 90 degrees for 285 minus 195, plus the cosine of 285 plus 195, which is 480 degrees. So to continue to be able to evaluate this, 480 is outside of my unit circle's range. So I'm supposed to subtract 360 from 480. So I get cosine of 90 degrees plus the cosine of 120 degrees, using that period of cosine. And now I can find the value of each of those expressions. So cosine of 90 degrees is 0, plus the cosine of 120 degrees, which is the upper left, same angle as before for sine. So that's going to give me -1/2 for cosine. Multiply this together gives me -1/4. Another way you can check to make sure this is the correct value, since this is negative, I can check to see what the values of these angles would have been. 285 is in my fourth quadrant, so that would have been a positive number. And cosine of 195, that's 195 is in my third quadrant, which would have been a negative number. So combined, that should give me a negative number. All right, next up, I have sine of 285 times sine of 75 degrees. And I can use that sine times sine product sum formula. Give me 1/2 of cosine of 285 degrees minus 75 degrees plus the cosine, oh, sorry, not plus, minus, using the minus there, the cosine of 285 degrees plus 75 degrees. Give me 1/2 of cosine of 210 degrees when I subtract 75 from 285 minus the cosine of 285 plus 75, which is going to give me 360 degrees, which is the same as 0 degrees for cosine since they are period 360 degrees apart. So when I go to evaluate this, I get 1/2 of cosine of 210, which would be in the fourth quadrant just under the 180 degree mark, giving me negative square root of 3 over 2. Then I'm going to subtract cosine of 360, which is a positive 1. So when I distribute the 1/2, I get negative square root of 3 over 4 minus 1/2, and I can find a common denominator, and that gives me negative square root of 3 minus 2 all over 4. Now let's try these just for expressions and how we can rewrite expressions such as this as 6 theta times 4 theta. That can be rewritten as a sum of two trig functions. I can use this formula right here, where I'll let 6 theta be my alpha and 4 theta be my beta. Using that formula, I get 1/2 of cosine of alpha, which is 6 theta, I should have closed those parentheses yet, minus beta, which is 4 theta, then minus cosine of alpha, which is 6 theta, plus beta, which is 4 theta. Give me the expression 1/2 of cosine of 6 theta minus 4 theta, which is 2 theta, minus the cosine of 6 theta plus 4 theta, which is 10 theta. Let's try with another one. Say we have 3 theta. Cosine of 3 theta times cosine of theta. I can let 3 theta be my alpha and just theta be my beta. And I can use that middle formula, which gives me 1/2 of cosine of 3 theta minus theta, alpha minus beta, minus cosine, plus, because now it's a plus in between, cosine of 3 theta plus theta, which just gives me 1/2 of cosine of 2 theta plus cosine of 4 theta. So now I went from my product to a sum. And lastly, I say I have sine of 3 theta, cosine of 5 theta. I can let my 3 theta be my alpha and my 5 theta be my beta. And that gives me, using the bottom formula, 1/2 of sine of 3 theta plus 5 theta plus sine of 3 theta minus 5 theta. Now when I go to simplify, something interesting happens here because I get sine of 8 theta plus sine of negative 2 theta. That is a negative coefficient inside of my sine function. So I can actually use that odd property for sine to move that negative out front. So now they're being subtracted instead of added. So I get 1/2 of sine of 8 theta minus sine of 2 theta. So again, I went from a product of sine and cosine to a sum of sines. And that is how you express trigonometric products as trigonometric sums.